Thank you. Hi, everybody. My name is Nathaly Villamor. I've been working as a software developer for the last 4 years of my career. And I must say that this is one of my biggest passions. I love to code, and I love to create solutions with code as a job. Further, I enjoy to contribute to the software communities. That's why I co-organize events like Rails Girls in Bogota, Bogota GS, GSCOM Colombia, Ruby Bogota, and others. And I love to spend my time in this because I love to return a bit of all of the good stuff I've been received in the last 5 years of my career. So first of all, I want to talk a little bit about my birth country. As some of you already know, I'm from Colombia, and I would like that people who has ever heard about Colombia raise your hand. Oh, nice. Well, I expect that when I say Colombia, you are thinking in some coffee, sports, vacations, lovely food, and of course, good developers. So, by the way, I bring some coffee for you guys. If you want, you can reach me later, and if you answer a simple question, you can win fresh Colombian coffee. So, dare to try. Well, currently, I'm working as a development lead in Waiko. Waiko is a Colombian company looking for a solution to save water. We already have an IoT device that controls the water flow in house pipelines. This device allow us to open and close a water valve, have insights about water use, launch alarms when the pipe gets broken or someone is doing fraud, and another cool stuff. So this is such a great thing because we can help aqueducts because they lost almost the 40% and they produce water in situations that they cannot control until someone warning them. So this is a tool that will increase the profits and save water at the same time. For now, Waiko is built thinking in a Colombian aqueducts model, so we would like to expand this to other countries that share our model in the future. For that purpose, we have been working in the entire process since the valve water until the interface for a whole year. Then this is a project that we built with love. Now, I want to introduce to my team. We are 5 engineers working in this project. One of them designs the hardware and the process to manage the water device. So in the development team, we are 4 engineers. It is composed by 2 junior developers and a mid developer, and me. And they are just learning basic concepts about Ruby and solid principles and other basic concepts. So when I say monads, you can imagine their faces. They were so confused, and I had some troubles explaining it. So I will talk about it later. Before to start, I want to tell you about our architecture. It is composed by a Ruby API, AWS IoT helper, a Vue.js frontend, a couple of lambdas, and for some little processes, we have a Neo4j database to have some data flexibility. And everything has been really entertaining to build, but our biggest challenge has been this state machine. It is an asynchronous process that involves all our platforms. So as a result, to write good code can be challenged, and even more for my rookie team. The thing is that this state machine is the most important feature in the platform because it controls the process between open and close the device valve. Therefore, it depends on many variables like the real device state, some counters to know how many tries the machine has made to change to a single state, some AWS IoT endpoints, Sigfox endpoints, among others. So we just created a hash to simulate the different objects that can be affected depending on the context. So we are going to to work with this, for this example, with 5 processes. These are the main things that we have to do when we want to change of a state, and we should execute these processes depending on some conditionals. These conditionals are made of variables that I just mentioned. I would like to notice that this piece of code is only works for when we want to open the valve, which means that in home we have a lot of scripts like this to refactor. As you can see, it looks pretty simple. However, it is fake. We need to replace this hash with code that will fail in any moment for many reasons. To make this happen, I wrote a sketch using one of my favorite monads, which is result. It is almost impossible for me to write a solution without result in my hand. So this is the first version. To explain this to my team, I started saying that that result is just a monad, and I used this image from Aditya Bhargava. Actually, he has a very helpful article. You should read it. This is the link. So, like Aditya, I explained how monads works, avoiding the explicit definition. The general idea is to wrap responses in boxes. These boxes are tagged with the data types depending on the monad type. I will explain it better later. I also mentioned other concepts like functors and applicatives and many more, but for now, monads are enough. Then I showed them a lot of creepy articles that talks about monads. Well, of course, it was hard to read. Well, I must admit that every time I read this, I realized that I know nothing about monads. So I resolved to simplify it as much as possible and then use some gamifications concepts to explain each monad with things that all of us understand. For this section, please, let's use our imagination for a while. We need a lot of imagination. So let's think, I like to think that developers has a mission, and our mission is to build solutions, right? So if I think that our mission as a game, we have goals to accomplish in each level. In games, we also have powers, so these powers are monads in my game. It is just a kind of game that I create using a little bit of every game I ever played, so don't judge me, please. Obviously, if it is a game about monads, well, we need a scary name. But do exist something scarier than the definition of monad? Or do exist something scarier than the 3 laws of monads? It was easy to find a name game, so a monad is just a monoid in the category of endofunctors, so please. So this is the map that I used for my explanation. Of course, they were more excited about monads after I used a Pokemon map in my game. So I drew a kind of labyrinth with many paths, but only one of them drives you to the main goal. In real life, it is like the happy path, like the famous happy path, and the other routes are the expected errors. In other words, those are possible parts in the game, but they carry to the side quest of the game. And it's expected, it looks like a real user story, like very toggle. So now, like every game, you have tools, you have powers or any help to get through obstacles and get the victory, right? So the first weapon I used was result. As I already said, I think this is straightforward to understand, so I call it the level 1 power. Now, imagine that you are walking through the map and you found 2 paths. How to decide which path we should take? Well, result can choose by using 2 data types, success and failure. So you just need to decide which path is success one and the failure one by wrapping the answer in a box and then tagging it with a success or failure. I think it's easy enough. And now that we dominate result, we are level 2 players. Let's keep walking, and now we face a bit of a monster. Our monster looks like a lot of sentences that can return nil or something else. That kind of thing forces us to add conditionals one after another. And at the end, we found that we have a lot of conditionals, and we have to draw everything to understand what is going on. To destroy them, we can use maybe. Maybe allow us to wrap each process in a box and return something or nothing depending on the sentence. That means that we can transform our monster in a pretty bunny. Let's see how. For instance, here I'm trying to get a device for some repository that can be a database or whatever you want. And if the device exists or not, I just send this answer to a maybe monad, and maybe now is in charge of return some or none, depending on the return value. Mm, in this way, I can convert this monad into a result, and they already know that nil means a kind of error, and some is a successful answer. And I think this is really cool because I can add my error type in this moment and do something at the end of the entire process without many code lines or some black magic. I will explain it better later. The second example is almost about the same, asking to a device repository for an update, and this line maybe update the object or maybe return a nil, just for the example. So let's continue leveling up because we know how to use result and how to use maybe and mix them all. The three-level monad is try. So at this point, my team understood how monads works in a general way, and I must say that my imagination was getting exhausted. So let's say that try destroys the final enemy. To use try, I only need something that can generate an exception, and AWS IoT is a good example. I just made up an exception for this example, and as you can see, you only need to wrap the process and add exceptions that you want to control, and then return a result monad. Of course, the result monad is just is not required, but I like to use it in order to have a kind of sequence like this. In this way, I can have control of my code pipeline and change the order or dependencies or whatever I want. So thanks to that, we can change the business requirements as many times as necessary in a simple way. For example, by injecting dependencies instead of making them all explicit. But maybe you are asking what happened with the conditionals. Well, here they are. I use a pattern matching to build objects that contains instructions to decide which actions should be executed in each case. And what about testing? Well, we can test each module independently and create a test that brings together the test cases for each conditional. So if you change the dependencies or something else, you will always have the control of everything you add or remove. Unfortunately, our project is built in Ruby 2.5.1, so when I get home, I will have to remove the beautiful pattern matching until we upgrade. So, do you remember that I mentioned something about error handling? Well, this is how to handle errors depending on the error object you send in the monads class. So I can send my monads result to an error handler method, and again, I use pattern matching to define how to resolve each error type. I can also return other monads, like maybe, with a specific value and manage that answer as you want. In other words, you can build as many paths as you want in your game app. It isn't great. Well, for me, it's such a way to know how a piece of code failed and how that error is being managed. If you apply this strategy in every new feature, it would be really easy to read your code or your partner's code. About this solution, I have some pros and cons. The first pro is that we can see so clear what is the process that is going on step by step, and yes, it looks like dry transaction. I love dry transaction, by the way. The second is that we can change dependencies as long the dependency returns a monad, and we can change the flow easily because all the conditionals are hosted in the same place. And even more important, the error handling has never been easier. As a cons, we have to visit another file to see what are the conditionals, in which cases one step is executed. And I haven't reviewed the performance yet, so I will have to do that when I return to home. And you need to learn some things before try to use monads. It's a kind of long path, but I guess if you understand how it works, you can get the most of it. So this is how I created Face for Monads, to have something more visual to understand. But it is important to read a lot until you choose a concept that you feel in your heart. For me, it is the Eric Meyer's monads definition. He says that monads are return types that guide you through the happy path. And I think it's true. It's a simple but powerful definition. And well, this is the team. Each one works differently and they fulfill a different function. Then we need to practice a lot to learn how to use them wisely. I couldn't use them all for this example because it's kind of hard, but each one has fulfill a different function. So you should use it for different situations. It is good to know about techniques like this. So in some cases, by applying the power of monads, we can untoggle nested callbacks, make parts of our code reusable, and generally make our programs better. However, all the team should be in the same page. Everybody needs to understand how it works and add some documentation for new developers. Because I was able to explain to my team how Monads works in a simple way, but even more important, all of them agreed about a way to use Monads and follow some rules to maintain our code clean and organized. Please don't try to force them for every case. They are not magical solution for everything. So I take these rules from a Bobby Prembobo article. I feel this is close to the way that we use monads in my team. He says that you should use a monad when the value may or may not exist, when the value may exist, but there are more than one of them, when we are getting a value from some kind of I/O operation, when the value may exist eventually in the future, we don't know, when the value may produce errors, which is the main reason to use monads, and the value may depend on some kind of state outside of the context that we are using, etc. In conclusion, you should use monads every time you feel that you need it. Don't force them. Of course, I use dry monads, but you can find another implementations like Kingsley and Stewart, so I invite you to check them all. And here are some documentation that I used. I think monads is a complex context, so you decide how far you want to go and how far you want to read. You can get crazy in the path, but it's okay. Just calm down. And remember that this is a mathematical concept, so it's not quite easy to understand, and it involves another concepts like functors, applicatives, endofunctors, categories, and many more. If you have questions, you can reach me in my social media or emails. And that's it. Thank you very much for listening to me. I appreciate a lot all the effort that the organizer team has made to help me, to bring me here today. Thank you to Open Race for finance my travel. It wouldn't be possible without your help. And finally, thank you to everyone for your patience and for your interest. Thank you. Questions?
So just one or two questions. Yeah.
Thank you. How was at the end of the training path for junior developers? Do they agree to use monads? Do they find, after your explanation, find it easy to understand and use, or what happened at the end of the story? Thank you.
Okay. Well, it wasn't easy. It was really hard because, as I said, they are just learning. So what I do always that we have a new feature or something, I let them implement the feature as they want. I just say, like, imagine that you are by your own and do whatever you can do. And then I try to show them how to fix some details that they, of course, use a lot of ifs and conditionals and things like that, and how can they transform this code with monads, follow the game that I made up. Okay. Somebody else? No? Okay, thank you. Gracias.